Hi, welcome to the Calculus 1 lecture series. We are in the unit number 1, the limits and the derivative. This is the second part of our lecture number 2, the limits of a function. All right. So the last, for the part 1 video, we talk about how do we define the limits. And then we set the limits, and then we divide it by the left-hand limit and the right-hand limit. That means you approach the value from the left-hand side or from the right-hand side. Then we come out with one very important result. We said, hey, if a limit exists, that means the left-hand limit has to equal to the right-hand limit. Right, and then we also introduced what is when we approach to A, and then my limits become to the infinity. We call it the limits, infinity limits here. Then we also talk about the vertical asymptote. So today we will continue working on the infinity limit and the vertical asymptotes here. Okay, so now let's go to continue our worksheets. All right, so we have completed this example from our first videos in the part 1, and find the limit of the right-hand limit and the left-hand limit. All right, so this one's here, we're going to put a lot more emphasis on the vertical asymptotes here. Okay, so the number 8 here, they say find the vertical asymptotes here. Okay, and sketch the graph. So we know what is the vertical asymptote is the one. So is the one, you approach to that number and will make it to the infinity or the negative infinity. That means is the derivative, not the, I'm sorry, the denominator equal to zeros, right? Okay, so now the first, let's see the vertical asymptotes here. I want to find what is the value, what are the value make the denominator equal to 0. That means x minus the absolute value of x minus 1 equal to 0, right? So that means absolute value of x equal to 1. So I will get x equal to 1 or x equal to what? -1. So those are the possible, those are the two vertical asymptotes here. Then I want to see what is my limits here, right? So those are the asymptotes here. So let's take a look here. Because when x equal to 1 is one of the asymptotes here, right? Okay, so now let's take a look at x approach to 1. So still remember what is this signs here? This is what from the right-hand side, right? So when the x approach to 1, so this is x and x minus 1, the absolute value of x minus 1. So remember, right, x approach to 1 from the right-hand side. That means x is always a little bit greater than what? Greater than 1. It's correct? All right, so if x is always a little bit greater than 1, so now I know in here, it will approach to 1, because this is always a little bit greater than 1. So 1 minus 1, so it's 0, but it's always a what? It's a little bit greater than 0. So what is this one? We know the denominator approach to 0, going to the infinities, right? Okay, so the same way is here. Let's take a look. If I have a limit x approach to 1, as we said, this one's here. What does this one mean? That means approach to 1 from the what? From the left-hand side. So it's x minus 1. Okay, so one more time, when the x from the negative sign, that means it's always a little bit less than 1. So if it's less than 1 minus 1, so what is going here is zeros, right? So what I have here, I have negative, right? So that means always a little bit less than 0. So what is this one going to approach to? Hey, it's going to approach to negative infinity. Okay, so now, all right, so now let's take a look at it, because I have another vertical asymptote is limit x approach to -1 plus here, okay? So here, the plus means what, right? So it's from the right-hand side, see here, right? Okay, so this one, be very careful, see here, right? So this one, when x is going to approach to -1 from the from the right hand side, that means it's always a little bit bigger than the -1. So like a -0.09 somethings, right? So in here I have a -1. All right, so now take a look here. So when x approach to the -1 from the right hand side, it's a little bit bigger than the -1, but the negative number bigger, that means you have like a -0.95, -0.98. Then you take absolute value become positive, right? So minus this one, -1 will be very close to 0, but is what type of close to 0? It's always what? A little bit less. So it's 0 to the negative. So what is the limit here? Because negative will give you positive infinities, right? Okay, so now let's take a look at this one here from the -1 to the right hand side here, right? Okay, so here let's take a look at this one here. This is x, this is x minus 1. Okay, so still the top here is -1. It's getting closer to -1. But now I'm getting closer to -1 from the left hand side. That means it's a little bit less than -1. But the negative less than -1. So for example, it's a -1.2, right? -1.009, right? So, but you take the absolute value of that value, what is going to happen? Going to be a little bit bigger than 1. Right, so when you minus here, you will have a 0, but what is here is always a little bit bigger than 0. So what is this one here? So this will give you the what? Negative infinities here. All right, so now like, based on this information, I can roughly sketch, okay? And I can roughly sketch it here. So I have a, okay, so let's write our asymptotes here. We know the asymptotes. We have a -1, we have a positive ones here, both of them to be my asymptote. So my graph here, I know if I approach to 1 from the right-hand side, I'm going to get the positive infinity. So I'm going to have like this way. And I approach to 1 from the left-hand side, I'm going to get a negative infinity. So that means I'm going to get like something like this. And then I approach to -1 from the right-hand side, I'm going to positive infinity. So like in here, then I approach to -1 from the left-hand side. So what happens here? I'm going to have here. So basically that is how my graph going to looks like, right? Because I know the asymptote, and so asymptote is pretty easy. It's just the denominator becomes 0. But how is the graph, the behave? That's how do you want to find, how do you approach from the left? How do you approach from the right? So, both here at the asymptote, they both like one end go up, one end go down, right? So the limit to the 1, the -1 does not exist here. All right. Okay, so now let's take a look at the number 9 here. We said, what is the limit here, right? Okay, so now, okay, so now for this one here, let's do here. I said, okay, the limit x approach to 3. Okay, so in here, if you say limit x approach to 3, okay, from the right hand side, x minus 3. So because it's always a bigger, so here you will have absolute value, the bigger. So you get a 0 positive here. So it's 1/0. So what is here? Infinities, right? And then the same ones here, you say, hey, limit x approach to the 3 from the left-hand side, the x minus 3. So, that means the x is always a little bit less than 3. So in here, I'm going to get very close to 0. So, but there will be a negative, right? That means it's always got some negative. Oh, but this is absolute value. Doesn't matter. I come out with a positive. So it's still what? It's still infinities here. So I know for this problems here, it's going to be what? Going to be infinity. Okay, now the next one is cotangent. All right, so now I'm going to find the cotangent from what? from the left-hand side here. So from this one here, I can look from the graph, see here, the cotangents here, right? So here, so this is a pi over 2, those things, right? Okay, so I know the cotangent graph is going to like this, kind of, right? So here. And then in here, I have here and I have here, right? So this is my cotangent graphs here. So take a look here. Because I am approaching to the 0 from the left-hand side, that means I'm going with this graph here, right? So what is the cotangent here? It's negative infinities here. Okay, so now let's take a look at this one's here. It's interesting. X approach to 3. All right, so we say X approach to 3 here. So let's say here, limit X approach to 3 from the right-hand side. Okay, let's take a look. What is this one? So approach to 3 from right-hand side. So the top approach to 3. That means the bottom here is 3 minus X. X approach to 3 from the right-hand side. That means what here? Is always something a little bit bigger, right? So if a little bit bigger than 3, then 3 minus x will be what? It's very close to 0, but it's always a little bit smaller than 0. So what is this one here? Will give you the negative infinity, correct? Okay, so now the same way is here. If I say limit x approach to 3 from the left-hand side, x the 3 minus x here. So the 3, so the x is still 3, but here I'm approaching to 3 from the left-hand side. That means the x is always a little bit smaller. If the x is always a little bit smaller, then 3 minus x is what? Is very close to 0, but it's always a little bit bigger than 0, right? So what is here? So it's infinity. Oh boy, so I find out, oh, this one is not equal. So the limit is what? Do not exist, right? So they have a vertical asymptote at x equal to 3, but one end go up and one end go down. All right, so now the number 10 is here. They said, oh, this one's easy. They just want to find the asymptotes, right? The vertical asymptote. So remember, what is the vertical asymptote? The vertical asymptote is a denominator equal to 0. That means x squared minus 4, x minus 3 equal to 0. So we know if two things times equal to 0, what's that mean? That means this one equal to 0 and this one equal to 0, right? So now I can try to solve this one here. So I will say the x squared minus 4 equal to 0. So the x equal to square equal to 4. So x equal to 2 and negative 2. But also I can say x minus 3 equal to 0. So what is x equal? X equal to 3. So how many vertical asymptote I have? I have 3, right? I have 3, the vertical asymptotes here is x equal to 2, x equal to negative 2, and x equal to the 3 here. Okay, so the last one's here, we said true or false, all right? So in here, they said, hey, if the limit of x approach to a, the f of x equal to the infinity and the limit approach to a, gx equal to infinity. Can I say the limit of x approach to a, fx minus gx will be equal to 0 here? Well, so what do you think? The problems here, this one's here is what is false, right? First, we don't know infinity minus infinity. We don't know it's equal to 0. See here. All right. So if you say, well, can you give me an example? I say, oh, yes. I would say, okay, so let's take a look, right? So the f of x, if I give you the f of x is 3 to the x squared. All right. And then I give you the gx is equal to the 2 to the x squared. All right, so this is simple. So you say limit x approach to 0, f of x. What is this ones here? They will approach to 0, the positive, right? So it's always a little bit bigger than 0, so it's infinity. So the same way the x approach to 0, the gx, what is here? This is 2 to the little bit bigger than 0, so it's what is infinity, satisfy this condition. Okay, so now let's take a look at f of x minus gx. So what is the f of x minus gx? And this one will just be what? 3 the x squared minus 2 the x squared. So it will be what? 1 over x squared. Now the limit x approach to 0, the f of x minus gx is equal to limit x approach to 0, 1 over x squared. What is this one? So this is 1 over 0 to the positive, so it's infinity. So it does not equal to 0. So this is, well, we're going to use this property later, right? So we know the 0 minus infinity minus infinity, we don't know what it could be, right? So it doesn't mean equal to the 0, doesn't mean always equal to the, the infinity. So for this problem here, the answer is false. So you cannot say that, right? So the infinity minus infinity is not equal to 0. Okay, that's it. I think this is our second lectures about the limits and limits of functions here, right? So our part 2 video, the key things to remember is, what is the key things to remember? Is the vertical asymptote, right? So the vertical asymptote is, to find the vertical asymptotes is pretty simple. You just let the denominator equal to 0, right? And then if you want to kind of see how is this asymptote perform and how is the graph perform, just like we did it in the problem number 8 here, then you need to look the limits from the right-hand side of the asymptote and from the left-hand side of the asymptote to see how they approach. So, all right, that's it. That is our lecture number 2. This is the part 2 videos here, okay? It's so nice to talk to you, and I'm looking forward. Let's go to our next lectures topics here. All right, bye. Have a good day. Bye-bye.